Hello everyone, this is Nick from ADC, and today we're going to go over a tutorial of XFLR5. So this will be broken down into multiple parts. In this first part, I'm basically going to go over what we went over last Thursday, which is how to go from an airfoil and airfoil tools all the way up to a 2D analysis of the airfoil. So first off, we're going to start by searching up airfoil tools, going to the website, and hitting airfoil search. Now, the reason that I'm going a bit fast is because this is a video. You're always free to go back and, lower the speed, things of that nature. So I might be going a little bit fast in this video, but you guys can always lower the speed, something like that. So for this airfoil search, basically, you need to take the airfoil that you found from your decision matrix and search that airfoil now. So for example, for me, look up 70 or SD8040, hit search. If you have a general airfoil type, some of the groups had this where maybe you chose reflexed or subsonic or semi-symmetrical as your airfoil type for your wing, go ahead and look up on Google some airfoils of that type and choose one. So once you have an airfoil that you chose, you want to find the source.file file button, right click it, and what I'm going to do is I'm going to create a folder and I'm going to put all of my files in this folder. Now, I don't recommend putting it in downloads. You can probably put it somewhere else. This is where I'm going to put it for now. So we have our .dat file. And now what we're going to do is we're going to open up XFLR5. Going to hit File, Open, and then you're going to open up our .dat file. If we're brought to a screen like this, you want to hit Module and go to Direct Foil Design. This is going to allow us to edit our airfoil. Now, looking at the airfoil, as you can see, there's no issues with it. It looks all nice and it's connected at every point. Let me just go in here real quick. Clark Y. Oh, that's not Clark Y. And then I'm going to grab this .dat file as an example. And I'll also grab a NACA 2412. So if I go ahead and insert both of those in here, as you can see, let me just hide the SD8040. The Clark Y, we have a line going through the middle of the airfoil and a line going all the way up here. So this is an example. So what we need to actually do to fix this is we need to manually edit the .dat file. So I'm going to go to my folder, go to where I have the files, and then it's the Clark Y, so I'm going to have to edit this. So the first thing we want to do is get rid of the header. The header does not matter for our purposes. And the second thing is that XFLR5 reads our coordinates from this point over here, this 1, 0 point. It's going to read it around to 0, 0, and then back on the bottom side to 1, 0 again. So it's going to make this loop. As you can see in this file, it's starting at 0, 0, and then it's going to 1, 0, but it doesn't hit 1, 0 exactly. So let's go ahead and change that real quick. And then it starts at 0, 0 again, and then it goes back to not 1, 0 exactly. You want to make sure that your points are exact. You don't want to hit, as you see, it was a little bit off of 0, 0. We want to make it exactly 0, 0. So I'm going to go ahead and hit save. And then I sorry. Click away. Oh wait, let me just delete this. As you can see, one of the issues is gone, and now we have the line straight from it. So in order to fix this, what we need to do is we need to reorder actually the bottom section of points is good here because that goes from 0 back to 1. We need to reorder this top section here. So basically, this point should be on the bottom, this should be second from the bottom. Basically, just flip this set of data points. So starting from here, this should be the first point, this should be the second point, this should be the third point, etc. So I'm not going to do that here. I don't want to waste too much time. So that's how you would fix the Clark-Y airflow. Now, if we open up, let's just take the Clark-Y airfoil off of here. And let's look at a NACA 2412. And here's another common error with airfoils. If we zoom in really closely, it is not touching here. Now this is a lot easier of a fix. We can just edit the DAT file, and then get rid of the header, and then basically we just make this 0, 0. Or 1, 0, sorry. 1, 0 exactly. It's exactly 0, 0 at one point, and then this needs to be back to 1, 0. If we save this, then delete this, and then reinsert it, you can see it's now fully connected, and that's what we want. So that's just some ways to address any issues you may have with airfoils being imported. So if we go back here, everything is nice and up to our standard. So now what we can do is we can actually prepare the airfoil. So what we are going to do is we're going to right click on the foil, hit derotate, bring this box up, hit OK. Then we're going to hit normalize. If you saw, it kind of moved a little bit whenever we did that. Basically, we're trying to, the airflow is going to be going this way. So it's going to be in the positive X direction. So it's going to flow like that. And so we need to make sure that the airflow is as in line with that flow as possible. Otherwise, our data is going to be wrong. So that's why we do that. Then what we want to do is right click on the foil and hit refine globally. Now, as you can see, we start with 61 panels. Some of you guys may start with around 30, 35. Others will start around 60. It's going to vary. For accuracy, I'm going to recommend 100 points. It's a good balance of accuracy and speed, because the more points you do, the longer it's going to take to analyze. As you can see, this foil looks a lot smoother now. And then finally, we're going to derotate again, and then normalize one last time. And so now we're done prepping our airflow. So far we have found our airflow on XFLR5, imported it, fixed any issues with the foil, and now we prepped it. Now we're going to hit Module, go to Direct Analysis, hit Analysis, and hit Batch Analysis. So as you can see, we can select the airfoils we want to choose at the top. So I want to choose our wing airfoil. Then here's a list of Reynolds numbers. This will be important for later on, but for right now, just keep it as it is. And then what we want to do is we want to run the analysis from a minimum of 0 to a maximum of 20. For you, it will probably look something like this, from 0 to 1. But go ahead and change it to go from 0 to 20. That way we can have a good range of angles of attack for our analysis. After you're done, go ahead and hit Analyze. And it should say Analysis Completed. So after you do that, you can hit Close, and you'll see a bunch of different graphs. Now, if your graph looks a little bit weird, you can click on the graph and hit R, and it'll redo the scaling of the axes, or you can right-click, hit Current Graph, and then hit Reset Graph Scales. And so that's going to be very important for getting the max coefficient of lift, which is going to be important for stall speed. So if we click on this arrow right here, we can see the range of Reynolds numbers. Now, Reynolds number is something we're not going to go into for ADC, but it basically characterizes a bunch of things for the flow. So for our application, we're doing low speed analysis, so we're only going to focus on the lower Reynolds numbers. So because of that, I'm going to go ahead and uncheck all these, and we're just going to worry about 40, 60, and 80. I probably have more Reynolds numbers than you guys do, but for you, 40, 60, and 80 should be right next to each other. And now what we want to do is we kind of want to get a good baseline for what um, our max coefficient of lift is. So that's going to be kind of this peak right here. So as you can see, I believe this is the 40 graph. Yeah, the 40 graph is the bottom one. So I'm more interested in the 60 and the 80. As you can see, it's around 1.25, 1.29. So you can use either of those numbers in your estimation. It's not really going to matter a whole lot. But yeah, that's how you basically perform the 2D analysis for an airfoil. And that's going to be the basics for what we're going to do later, where we're going to do a 3D analysis. Oh, and I forgot to mention, once you've finished all this stuff, make sure you hit the save file, and then go ahead and I'm going to name this wing because we're going to make 3 different project files. One with the wing only, one with the tail only, and then one with the entire plane. So everything we've done is for the wing, so we're just going to call this the wing file. So go ahead and save that, and make sure, every once in a while you just either hit this save button here or you hit Control S.